Hmm. Do you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
So in this class, we are going to discuss how to find out largest eigenvalue of a matrix and its corresponding eigenvector. Do you recall you have studied eigenvalues and eigenvectors at some point in semester 2? Do you recall? Okay. So let us quickly revisit the concept. Eigenvalues and eigenvectors. These concepts are very important in engineering problems. So suppose you have a matrix. N cross N matrix is given to you. Okay. So how many so first let us consider what is eigenvector. So a non-zero vector x is said to be eigen said to be a an eigenvector of a if and only if a of x equals to some lambda into x. Lambda is an element of the field. Vector space किसी field के ऊपर defined होते हैं. So in general, lambda will be some real number or complex number. Okay. So lambda will be belonging to real line or complex field. So this vector x, non-zero vector x, which is satisfying the relationship x equals to lambda x for some lambda belongs to R or C, is called eigenvector. And this lambda, this is called eigenvalue. So this is a mathematical expression. What is the meaning of that expression? So you will be looking for that non-zero vector in Rn, since the matrix is of n cross n, so you will be looking for vector in Rn. So if the matrix is of order 3 cross 3, you will be looking for a vector in R3. If the matrix is of order 2 cross 2, you will be looking for a vector in R2. So you will be looking for a non-zero vector x in Rn such that that vector is not changing its direction after matrix multiplication. If you pre-multiply the vector by the matrix A, you will get another vector lambda time x. So you see lambda time x and the original vector x, do they change direction? Are they changing direction, x and lambda x, if lambda is a real number or complex number?
No,
No,
sir.
no, it is not changing its direction. They are on the same direction. Okay, since x is multiplied by lambda, so x and lambda x, they will be of different size, is not it? So you are looking for that non-zero vector x which is not changing its direction after the matrix multiplication. Only its length will be changed. Either it will be stressed or it will be shrinked. So by factor lambda is the factor by which the vector x has been stressed. Okay. So that lambda is called the eigenvalue corresponding to the eigenvector. Okay. So now this eigenvector concept has huge application. We have already seen one such example in solving system of linear equation. We have seen that when we are applying Gauss-Jacobian Gauss-Seidel iteration scheme, the necessary and sufficient condition for the convergence of those scheme is that the largest eigenvalue of the iteration matrix has to be less than 1. So how to find out the largest eigenvalue? You should have some procedure. You should have some technique to find out the largest eigenvalue. Also, eigenvector is that vector which is not changing its direction. So in many practical problems when you need to discuss the stability of a system, for example, you want to discuss the stability of an aircraft. So several forces will be applied on the wings as well as the body of the aircraft, airplane. So the vector, the force component can be written in terms of matrix form. So if you consider tensor in 3 dimensions, that will have 9 components. So it will be written as a matrix in 3 cross 3 form. So you'll be looking for that direction along. So you will be looking for that vector which will not be changing its direction. So that you can obtain by this eigenvalue technique. Another, so if you consider this, let us consider a simple example. So let us see another application of this concept, eigenvalue, finding eigenvector and eigenvalue. So suppose in a hypothetical situation, you have a large building, multi-storied building, which is affected by some virus. So this is the building perimeter. It is separated from the outside world. And initially, let's say some m naught numbers of men are there. M naught men are there, and let's say Z naught. So these are the number of zombies. Z naught zombies are there, and these are the number of healthy people. Healthy people. Now, what is happening there inside that building? Due to some virus, 20% of human or men will be converted to zombies each day. Are you following? Students, are you following me? Are you
Yes,
following the
sir.
situation?
Yes, sir.
And some cure is there, some sort of vaccine or serum is there. For that, you can cure some zombies and you can convert them to people again. So suppose 10% of zombies will be converted back to human form each day. So what will happen? What will happen if you take different initial human being and different initial zombies? What will happen to this system after a large amount of time? Let's say after 1 year or after 2 years or after 10 days, depending on the number of initial peoples, initial men and zombies. So what is your intuition? What is your intuition? What is going to happen? Suppose some amount of, let's say 20 zombies are men are there, and let's say 100 or let's say 10 zombies are there. Then what is going to happen to this system? What will happen? Are all men going to convert to zombies, or all zombies will be converted to human? What will happen to this system with different initial men and zombies? Suppose in one situation 20 human beings are there at the beginning and 10 zombies are there. What will happen? Any guess? Make a guess. It is not like it has to be
So all
correct.
will convert to zombie.
All the human beings will be converted to zombies.
Yes, sir.
So that is your intuition. So that is not correct. They will reach to an equilibrium position. They will reach to a fixed number, and after that no more changes will be there. I can give you one such example. Let us take 10 human being and 20 zombies at the beginning, at the starting day. Suppose you have 10 human beings and 20 zombies. What will be the human being next day? What will be the number of human beings? What will be the number of men next day? And what will be the number of zombies next day? So 10 में से कितने लोग घट जाएंगे? जो ह्यूमन से zombies हो जाएंगे, कितने लोग? 20%.
One.
So 20%, 10 का 20% कितना होते हैं?
8. 2.
2. तो 10 में से 2 कम हो गया, सो दिस विल बी नंबर ऑफ ह्यूमन बीइंग। और ये भी देखो कि 10% ज़ॉम्बीज ह्यूमन बीइंग होंगे। सो इनिशियली 20 ज़ॉम्बीज आर देयर, तो कितने ह्यूमन बीइंग उससे मिलेगा? 10%। सो व्हाट इज द 10% ऑफ 20?
2.
2। सो प्लस 2 ऐड करने होंगे। सो कितना हो गया टोटल? नेक्स्ट डे -2 + 2 will be cancel out, it will remain same, 10 human being. Is not it? zombies की क्या
Yes,
होंगे?
sir.
20 zombies थे इनिशियली, और कितने zombies मिलेंगे मेन से जो कन्वर्ट होंगे, वायरस से अफेक्टेड होंगे? 20 + 20% of men, so 20% of 10 is how much? 2। सो 2 बढ़ेंगे, लेकिन क्योर भी तो है ना, तो उससे 10% zombies ह्यूमन बीइंग बन जाएंगे, तो माइनस करने पड़ेंगे 10% ऑफ द zombies. So initially 20 zombies are there, so what is the 10% of 20? So 2, so you have to subtract that. So again you see it is remaining 20. So this is an equilibrium point. Okay, it is not like this is the only solution. If the starting value of main and zombies is 15 and 30, again there will be no changes in the subsequent days. If it is 20 and 40, there is no changes in the subsequent days. So you see all those values which are lying in the line. So if this axis is main axis, number of men, and this side is zombies, so any starting number of zombies and men which will be lying on this line, they will not be changing in the subsequent days. All of these values are equilibrium point. If you start with any other values, any other non-zero values, so after a subsequent amount of time, they will be converted, they will be converging to a point on this line. If you take any other values, initial values, other than the points on the line, they will be converging to a point on this line. So this line is y equals to 2x. In vector form, it can be written as k comma 2k. So this vector will be not changing its direction in matrix multiplication. So what is the matrix here for this system? So suppose in nth day population of men is, let's say, mn, and population of zombies are that is zn in nth day. So what will be the population in n plus 1th day for men? So mn plus 1 will be 20% of mn plus 10% of zn. And what will be the zombies? So it will be zn plus 1 equals to 10%, 2% will be obtained from men, or 20%. Sorry, it is 80%. 80% will be remaining men. So 20% will be coming from men, women, plus 90% will be remaining from zombies itself. So 90% of zn. So if you write down in matrix form, you are getting mn plus 1, zn plus 1 equals to 80% of mn, that will be 0.8. So 0.8, 0.1, 0.2, 0.9 of this vector zn, mn into zn, mn zn. So you are getting this matrix. This is the matrix of the system, and if you find out the eigenvalue of this matrix, you will get this vector. Eigenvector of this matrix will be k and 2k. K is any real number. So इस वेक्टर के ऊपर जितने भी पॉइंट्स होंगे वो सारे वेक्टर होंगे इक्विलिब्रियम पॉइंट. अगर कोई दूसरे पॉइंट चूज करते हो, so that will be converging to a point on this line or on this vector. So you see, your aim was to find a find an eigenvector of the matrix. You can check it is an eigenvector. If you multiply 0.8, 0.1, 0.2, 0.9 to this vector k comma 2k, let's see what happens. It should not change its direction. K comma 2k should not change its direction. So tell me how much you are getting. 0.8k plus 0.2k. 0.2k plus 1.8k. How much you are getting? K 2k. So you see, initially you had this vector, at the end also you have the same vector. Multiplied factor is 1. So k comma 2k is an eigenvector for arbitrary k belongs to R, and 1 is the corresponding eigenvalue. So you only have to find out eigenvector of the matrix. So these are some hypothetical situations. Similarly, predator prey problem. For example, if in an environment certain amount of foxes are there and certain amount of rabbits are there, so their rate of change, the rate of change in their number will be given by some differential equation. For example, if at any moment number of foxes will be, the change of number of foxes will be df by dt will be proportionate to the number of foxes. In an environment only foxes and rabbits are there. So foxes and rabbits are there. So foxes, they are surviving, they will be dying due to natural cause. They will not be eaten by rabbits. So their population, their change will only be depending on themselves. So df by dt will be proportional to the number of foxes present at that moment. So it will be k times f. Df by dt will be k times f. This is the differential equation which represent the rate of change of the number of foxes. And what will be the rate of change of number of rabbits? Dr by dt. So they will be, again, they will be proportional to the number of rabbits present at that moment, but their rate will be much more compared to the foxes. Otherwise, fox will eat the rabbits and they will eventually vanish, but which is not going to happen. So that rate will be bit more. So maybe that is 3 times k of rabbit, and some of the rabbits will be eaten by foxes. So suppose minus k into f. So this is the rate of change in the number of rabbits. This is the change of rate in number of foxes. So if you see, this can be written in matrix form. Df by dt, dr by dt, that will be equals to k 0, 3k minus k into f r. So you see, you have written for a certain environment, k will be fixed. It will be determined by the environment. So you have obtained a matrix. So what will be the equilibrium of the system? Whatever initial value you take, that will be converging to an eigenvector of this matrix. So this problem is known as predator-prey problem. Predator-prey problem. So this is an eigenvalue problem. You have to find out the eigenvalue and its corresponding eigenvector. Okay. So we are going to learn how to find the largest eigenvalue and its corresponding eigenvector. So suppose A is n cross n matrix, n cross n matrix, and it has eigenvalues. It has eigenvalues lambda 1, lambda 2 up to lambda n, such that, so you have n number of eigenvalues for a n cross n matrix, is not it? जो how to find out the eigenvalues, this is the equation which you have to solve, determinant of a minus lambda in. So you have to solve this equation. So this will be a polynomial equation in lambda of degree n. So polynomial equation in lambda of degree n has exactly n roots, both considering real and complex roots. Oh, so that is why I am saying, suppose it has eigenvalues lambda 1, lambda 2 up to lambda n such that we have arranged them in increasing order, sorry, in decreasing order. Lambda 1 greater than lambda 2 greater than equals to lambda 3 greater than equals to lambda 4, so on up to greater than equals to lambda n. You look at the sign here. This inequality, the first inequality has to be greater than, strictly greater than lambda 1 greater than lambda 2 greater than equals to lambda 3 greater than equals to lambda 4 and so on up to lambda n. So first, so what is the meaning of that? There should be only one maximum eigenvalue. Maximum eigenvalue should be of multiplicity 1. That should be a lone eigenvalue. Did you get my point? जो मैक्सिमम आइगन वैल्यू होंगे उसको सिंगल होना है. सिंगल होना मीन्स दैट आइगन वैल्यू शुड बी ऑफ मल्टीप्लिसिटी 1. There should not be any other factor lambda minus lambda 1. So this determinant of a minus lambda I equals to 0 should not be written as lambda minus lambda 1 power square or cube or into some other part p lambda x. It should not be written in this way. If it is written in this way, then lambda will be occurring twice. So lambda 1 will be occurring twice. So multiplicity of lambda 1 will be 2. This should not be the case. Largest eigenvalue should be occurring only once. It should be of multiplicity 1. And remaining eigenvalues, they may be same. It does not matter. So we want to find this eigenvalue. We want to find this. We want to find this lambda 1. So suppose x1, x2, students, are you listening?
Yes, sir.
Yes, sir.
Yes, sir.
Suppose x1, x2 up to xn are the n vectors in Rn such that which are eigenvalues. Suppose x1, x2, xn are the n vector in Rn, which are the eigenvector, which are the eigenvectors corresponding to eigenvalue lambda 1, lambda 2 up to lambda n. Okay, so what you have? You have this equation axi equals to lambda I xi I equals to 1, 2, 3 up to n. n आइगन वैल्यूज है. हर एक आइगन वैल्यूज के लिए आपको एक आइगन वेक्टर मिलेंगे. एक नहीं, एक से ज्यादा भी मिलते हैं. Because the eigenvectors are not unique. If V is an eigenvector, then some constant into V is also an eigenvector. So suppose x1, x2 up to xn are some eigenvectors corresponding to the eigenvalues lambda 1, lambda 2 up to lambda n. So axi equals to lambda ixi. This is known to you. Remember, we are deriving the formula. So now, so one more condition is that these eigenvalues should be these eigenvectors should be linearly independent. मतलब क्या है? n क्रॉस n मैट्रिक्स के n linearly independent eigenvector होना चाहिए. अगर किसी मैट्रिक्स के नहीं है तो आप पावर मेथड जो हम लोग डिस्कस करने जा रहे हैं वो यूज नहीं कर पाएंगे. So this is another restriction on the matrix. The matrix should have n linearly independent eigenvectors. So which we are assuming एक मैट्रिक्स के n linearly independent eigenvectors नहीं भी हो सकते हैं, but to apply this method it must be. So anyway, we have assumed x1 x2 up to xn are the eigenvectors corresponding to the eigenvalues lambda 1 lambda 2 up to lambda n. So this redundancy is satisfied. Now dimension of Rn is n. Dimension of Rn is n. So any linearly independent eigenvectors, n linearly independent eigenvectors in Rn will form a basis of Rn. So if you take any initial vector v, if you take any initial vector v, or if you take any initial vector x, that can be written as a, since x1 x2 up to xn are linearly independent and dimension of Rn is n, so these vectors are a basis, these vectors form a basis of Rn. So any vector x can be written as a linear combination of the basis elements. So x can be written as c1x1 plus c2x2 up to cn xn. Now you pre-multiply this vector by the matrix A. So what will be ax? Ax will be c1 ax1 plus c2 ax2 up to cn axn. So use the relation given in 1. So what you will get? C1 lambda 1 x1 plus C2 lambda 2 x2 up to so on Cn lambda n xn. Now take lambda 1 common. So lambda 1 will be C1 x1 plus C2 lambda 2 by lambda 1 x1 up to Cn lambda n by lambda 1 xn. So if you pre-multiply this Ax vector by again A matrix, so Ax is a vector, you pre-multiply this vector by A. So you will get A square x. A square x will be A into Ax. So that will give you lambda 1 square C1 x1 plus C2 lambda 2 by lambda 1 square x1 up to so on Cn lambda n by lambda 1 square into xn. This is going to be the relation. Okay. So if you apply this procedure, same procedure, if you repeat the step, so what will be a power n into x? You are pre-multiplying x vector by the matrix A n times. What it will be? The resulting output will be lambda 1 power n c1 x1 plus c2 lambda 2 by lambda 1 power n into x2 so on up to cn lambda n by lambda 1 power n xn. What will be an plus 1? You replace n by n plus 1. So an plus 1 will be an plus 1, x will be lambda 1 power n plus 1 c1 x1 plus c2 lambda 2 by lambda 1 power n plus 1 up to cn lambda n by lambda 1 power n plus 1. Or let us use the symbol k because n is already present in the dimension of the matrix. So let us use the symbol k. Let us use the symbol k. So k plus 1 will be k plus 1, k plus 1, here it will be k plus 1 into xn. So this is the expression you have obtained. Now can you tell me what will be happening to lambda 2 by lambda 1 power n or lambda 2 by lambda 1 power k as k tends to infinity? What will be happening to this expression as k tends to infinity? What it will be? You look at the relationship between the eigenvalues. Lambda 1 was greater
0.
than equals to lambda 1 was greater than lambda 2, greater than equals to lambda 3, greater than equals to lambda 4, and so on. So lambda 2 by lambda 1 is less than 1. Lambda 3 by lambda 1 is less than 1. Lambda 4 by lambda 1 less than 1. All these values are less than 1. So if r is less than 1, so if r is less than 1, I also should use the modulus, otherwise you may get negative values. So I should mention here these mods are involved. Otherwise you may get negative value, and that may be a bit difficult to handle. So you have this mod. So what will be happening to this? What will be lambda 2 by lambda 1 power k as k tends to infinity? Mod is there.
0.
That will be 0. Similarly, lambda 3 by lambda 1 power k also will be 0 as k tends to infinity. In general, limit k tends to infinity, lambda I by lambda 1 power k will be 0 for all I from 2, 3, 4 up to n. So for large n, what will be happening to these terms? For large n, what will be happening to these terms? They are all going to be 0. Okay. So for large n, what you will get? A power k into x will be approximately equals to lambda 1 power k c1 x1, and a power k plus 1 x will be also similar, approximately equals to lambda 1 power k plus 1 c1 x1. Is it okay? This will be giving you this, and this line will be giving you this. Is it okay? For large k, not n, for large k. Yes or no? So now what you do? So left hand side you have a vector, right hand side you also have a vector. So to get the value of lambda, what you do? So this equation is capital A, and this equation is capital B. Divide B by A. Divide B by A means you are taking component wise division. Right hand side will be cancelled out because they are same vector. So all component will be 1, 1, 1, 1, 1 on lambda 1 into 1, 1, 1, 1, 1. So lambda, so B divided by A, that will give you lambda 1 into 1, 1, 1 up to 1. How many 1? N times. Okay, that will be what? A power k plus 1 into x by a power k into x. So this has r component. Okay, it has r component, it is a vector. So if k plus 1 is, if this is a vector, let's say that is v1 v2 up to vn, and ak x is, if that is w1 w2 up to wn, basically you are talking about this ratio v1 by w1, v2 by w2 up to vn by wn. Is it okay? So that is what you are talking about. So you see, lambda 1 can be taken. So left hand side we have lambda 1, lambda 1, lambda 1 up to lambda 1 n times. N times. N times. What we have on the right hand side? We have these n coordinates v1 by w1, v2 by w2 up to vn by wn. So what will be lambda 1? Any of these ratio, all these ratio, they will be converging to same value as k is tending to infinity. So any ratio you can take as an approximate value over the largest eigenvalue. Okay. So let me write down in formula. So lambda 1 will be limit k tends to infinity a k plus 1 into x by a k x, its rth coordinate. It will have n coordinate, so you can take any coordinate of that vector. What is r? r equals to 1 2 3 up to n. तो कोई भी r के लिए आप वो रेशियो ले सकते हैं. So this is the idea of power method. You are choosing an initial guess x and you are repeatedly multiplying x, pre-multiplying x by the matrix A. And if you do it for sufficient large number of times, then you have to take this ratio, and that ratio will give you the maximum eigenvalue. You only have to consider the modulus, because in convergence of Gauss-Jacobi and Gauss-Seidel, you only need the magnitude of the eigenvalue. So once you get the magnitude, exact eigenvalue will be either with positive sign or negative sign. So one time you put the positive sign of maximum eigenvalue in the characteristic equation. If the characteristic equation is satisfied, so eigenvalue will be of positive sign. If it is not equals to 0, if characteristic equation is not satisfied, then you put negative value of that lambda and you substitute again in the characteristic equation. If that one of these will be satisfying the equation, either whatever lambda you are getting, you one time you substitute with plus sign, another time you substitute with minus sign in the characteristic equation. One of them is going to satisfy the equation. So if sign is required, then you have to do that. And if only modulus is required, then anyway you take the positive value. Okay. So this is the procedure. Now this power method can also be used. The power method can also be used to find out the smallest eigenvalue. How? So this power method can also be used to find smallest eigenvalue. Smallest eigenvalue in magnitude. How? So you know this result. Which result? Suppose lambda is an eigenvalue of A. Eigenvalue of A. Then what you have? There exists x not equals to 0, non-zero vector x, such that what happens? A time x equals to lambda time x. Okay. So now what you do? You pre-multiply the equation by A inverse. So A inverse A into x is lambda into A inverse x. So what is A inverse A? What is A inverse A? Identity matrix. So identity matrix into x will give you x only. So x equals to lambda A inverse x. So in other way, if you write A inverse X will be lambda inverse X. जो lambda है left hand side में, let me first write down one more line, otherwise you will get confused. So it is 1 by lambda into X, so which is lambda inverse into X. So what is the meaning of this last line? Last line tells you that if lambda is an eigenvalue of A, then lambda inverse is eigenvalue of A inverse with respect to same eigenvector. If lambda is an eigenvalue of A, then lambda inverse is an eigenvalue of A inverse with respect to the same eigenvector capital X. Okay, so this result will be used. So if lambda 1, lambda 2 up to lambda n, these are eigenvalues of A. Suppose these are eigenvalues of A. Then what are the eigenvalues of A inverse? What are the eigenvalues of A inverse? Remember, inverse exists means determinant is non-zero. If determinant is non-zero, 0 cannot be an eigenvalue. So lambda 1 inverse, lambda 2 inverse, up to lambda n inverse, they will be eigenvalue of A inverse. Eigenvalue of A inverse. So what will be your aim? Find out the largest eigenvalue of A inverse. Find out the largest eigenvalue of A inverse. Find the largest eigenvalue of A inverse. तो A inverse की जो largest eigenvalue होंगे, that will be the smallest eigenvalue of A. Yes or no? If lambda is largest, then 1 by lambda will be smallest. If lambda 1 is largest among lambda 1, lambda 2 up to lambda n, then 1 by lambda 1 is going to be smallest among 1 by lambda 1, 1 by lambda 2 up to 1 by lambda n. You know that? So what you are doing basically, you are finding the largest eigenvalue of A inverse. Once you get the largest eigenvalue, you take the inverse of that. That will be the smallest eigenvalue of A. Okay? So suppose in n number में से कोई एक lambda के इनवर्स लार्जेस्ट हैं, कोई एक lambda के इनवर्स लार्जेस्ट हैं. So that is the largest eigenvalue of A inverse. Then what will be the smallest eigenvalue of A? Lambda k. Lambda k will be the smallest eigenvalue of A. So this is how power method can be used to find out the smallest eigenvalue also if you want. And eigenvector is not changing. So जो eigenvector lambda inverse के होंगे, lambda के भी same ही होंगे. You see, they are not changing. So eigenvector की आपको दूसरी बार निकालने की जरूरत नहीं है. Now let us understand this method with simple example. Just a moment, I will explain this with the PDF. Just a moment, let me find out, because this will be a simple matrix multiplication. I do not want to do the calculation. Just a moment. What is the PDF? Even same, what same? ECE, old files, lecture notes. Okay. Okay. Do you see my screen, students?
No, sir. Yes, sir.
Okay. So here, this is the part of the syllabus. Uh, I'll be uploading this lecture, this PDF in class material folder. So you see, we are discussing power method. Okay, same technique what I have explained, that is there. Now, first we'll be discussing in short with 2 cross 2 examples. We'll be considering a 2 cross 2 matrix. So this is the example. Find out the dominant eigenvalue, means largest eigenvalue in magnitude of the matrix 1, 2, 3, 4 by power method. Okay. So what you have to do here, basically they have used normalized approach. They have used normalized approach. So let me show you. If you do not use normalized approach, what will happen? So I taught the same thing to E batch at some today only, I think. So I'll show you the calculation. Let me go to the last page. Yes. So you see, you have the matrix. What is the matrix here? 1, 2, 3, 4. You see that same matrix. 1, 2, 3, 4. You have to find out an dominant eigenvalue, the largest eigenvalue of the matrix A. So you take, you choose an initial guess. It should not be 0. You choose any initial guess other than 0. So I am choosing 1, 1. So this is the initial guess. Okay, this is the initial guess I have chosen. Now what you do, you keep on repeatedly pre-multiplying the vector by the matrix A. So AB will be the matrix 1, 2, 3, 4 into multiplied by the vector 1, 1. So that will give you 3, 7. Again, you will have to pre-multiply that vector 3, 7 by the matrix A. So A square V will be A into AB. So 1, 2, 3, 4 into the vector 3, 7. So that will give you 17, 37. A cube V. So again you will pre-multiply that resulting vector 17 and 37 by the matrix A. So that will be A cube B. A cube B will be 1, 2, 3, 4. That matrix into the vector 1, 7, 17 and 37. So that will give you 91, 199. Okay. Again, you keep on pre-multiplying the vector with the matrix A. So A for B will be 489 and another component will be 1069. So I have repeated the procedure 6 times, and after 6 times pre-multiplication of the vector V by the matrix A, we have ended up with this vector. The vector is 14113 and 30853, and the vector previous to that calculation is 2627 and 5743. So this is simple calculation, simple matrix multiplication to a vector. Okay. So if you stop at this point, so if you use hand calculation, either you will be stopping here or you will be performing the multiplication few more time. So suppose I am stopping at 6th iteration. So what will be the dominant eigenvector and corresponding eigenvalue? So what will be lambda? What will be the dominant eigenvector? Dominant eigenvalue. So you have these two vectors. You just a moment. So you have, this is, let's say u is 2627 5743. This is u, and you have another vector in the next iteration, that is 14113 and 30 853. So this is u, this is v. So what will be lambda? Lambda will be the ratio in the division w by u. So what is w by u? W by u, what is that? You have to take component wise division. So 14113 by 2627, comma 30853 by 5743. So both of them will be coming 5.372. I have already told you all these components will be converging to same value 5.372. So that will be lambda. Lambda will be any rth component, whatever component you want. Basically, they will be converging to same value. So what will be the dominant eigenvalue? If you stop at sixth iteration, then the dominant eigenvalue will be 5.372. And what will be the corresponding eigenvector? ये वेक्टर जो आपको मिले हैं राइट हैंड साइड पे लास्ट इटरेशन पे जो वेक्टर मिले हैं, so that will be the eigenvector corresponding to the eigenvalue 5.372. Okay, so this is how power method works without normalization technique. What is normalization technique? I'll tell you. You see the disadvantage of this method. As you keep on pre-multiplying the vector v by the matrix A, these values are getting large. You see, initially it was 1, 1, then 3, 7, then 17, 37, then 91, 119, 199, then 489, 1069. So these values are getting large. So to avoid round up error, normalized approach is used. So what is the normalized approach? So let me discuss the normalized approach from the PDF. So your aim will be to choose an initial guess. So you are choosing an initial guess V0. Then from this V0, you will end up with your ultimate eigenvector and its corresponding eigenvalue. Your answer will be here. So how to reach from V0 to that answer? So V0 is initial guess at kth iteration. At kth iteration, what will be the output value? Output value will be, you will pre-multiply the vector Vk by the matrix A. Okay. Now what you have to do? You have to normalize the vector Yk plus 1. How to normalize the vector Yk plus 1? You have to consider the largest component in Yk plus 1 and by that value you divide each component. While doing so, what will happen? Largest component in the modified vector will be 1. So that is what you have to do. You have to make largest component in the vector to be 1 so that the values does not increases rapidly. So you look for mk plus 1. Mk plus 1 will be largest component in yk plus 1. So you see it is written here. I do not want to overwrite. So you see, you are choosing an initial guess V0, then at kth iteration you are getting yk plus 1, which is pre-multiplication of the vector V by the matrix A. Then Vk plus 1, the new vector. You in kth iteration you have Vk, you want to get Vk plus 1. So what will be Vk plus 1? Vk plus 1 will be Yk plus 1 by Mk. You are dividing each component of Yk plus 1 by the largest component of Yk plus 1. You see, Yk plus 1 by Mk plus 1. Mk plus 1 is real number. Real number. And Yk plus 1 is vector. So Yk plus 1 by Mk plus 1 means what? You are multiplying each component of yk plus 1 by mk plus 1. Okay, so after large k, when you have considered sufficient number of iteration, what will be the dominant eigenvalue? Dominant eigenvalue lambda 1 will be yk plus 1 by vk. Yk plus 1 is the vector, vk plus 1 is another vector. So this basically you are dividing component wise. So r components will be there in this division. So you can take any of those r components, that will be giving you the dominant eigenvalue, and vk or yk plus 1, whatever you take, that will be the corresponding eigenvector. So you see this technique in this example. So here 1 1 has been chosen as an initial guess. So what is y1? Y1 is pre-multiplication of the vector b by the matrix A. So 1 2 3 4 into 1 1. So this is 3 into 7. So this is y1. So from y1 we have to find out v1. So what is v1? V1 is nothing but y1 by m1. What is m1? M1 is the largest element in y1. So what is the largest element in y1? 3 or 7? 7. So that is why m1 is 7. So what is the next approximate eigenvector? v1. v1 is y1 by m1. So this is 1 by 7 into 3 7. So you are getting this. So next, what will be y2? y2 will be a into v1. So a is 1 2 3 4, that matrix, into v1. v1 is 0.428571. So you have obtained this as y2, this circle vector as y2. What will be m2? m2 is the largest component of y2, so it will be 5.28571. So m2 is 5.28571. So what will be next approximate vector? So from v0 you have obtained v1. Now you need to calculate v2. So what will be v2? v2 will be y2 by m2. You have to normalize y2. So you divide each component of y2 by largest component of y2. So that is what we have done. So you have normalized the vector y2 and you have obtained v2. From v3 you have to calculate from v2 you have to calculate v3. So to get v3 you have to first calculate y3. So y3 is a into v2, and same thing will be repeated. So you see the iteration procedure has been stopped at y6. So y6 is this value, v5 is this value. So what is the dominant eigenvalue? Lambda is this ratio, 2.45743 by 0.45743, 5.37229 by 1. तो इन दोनों में से जो भी आप चाहे ले सकते हो, कोई भी रेशियो ले सकते हो. Both of them will be same. First one also will be coming, let me see, 5.37225. So first one is coming 5.37225. This is first component. Second component is coming 5.37229. So any one of them can be taken as dominant eigenvalue. So if you stop at sixth iteration, and what will be the corresponding eigenvector for the eigenvalue 5.37225? Any one of v4 v5 or y6, इन दोनों में से कोई ले सकते हो. Basically one is constant multiplication of other one. Okay, so this is how power method works. So this was for 2 cross 2 matrix. Another example is there for 3 cross 3 matrix. You have to find out the dominant eigenvalue. Same technique. Okay, so this is the way you are finding dominant eigenvalue or largest eigenvalue in magnitude. Okay, so I'll upload this PDF in the class material folder. I'll stop the discussion at this point. So this unit is completed.